All right, so we're going to talk about marking pictures. So what we mean is how to mark pictures to help identify congruent pieces in a figure. So what we know is that if you want to mark sides congruent, remember that's just a dash mark on the lines. So this marking tells me that all three of these sides are now congruent. If I want to mark an angle, I'll put an arc inside the angle. And this one identifies that all three of these angles are the same. Now, if I wanted to say that not all of them are equal, I would just double the amount or add extra arcs. So now for this, I would know that these two are equal, but not to that one, okay? Or they're congruent. So remember, for the sides, you use the like slashes, and the angles, you use arcs inside of the angle. So we want to find some different ways how we can mark the sides congruent. So one way is if it's given to you, told to you. So if you have a problem and they say side AB is congruent to side CD, then you already know those are congruent. You can go ahead and mark those. But then there are also some ways that you're given information that implies sides are congruent and they're not explicitly stated. And so I want to go over a couple of those examples so you know what to do when you see them. So one example would be if you have something that talks about a midpoint. So in this one, you have M is the midpoint of segment KL. Well, here we go. We have M is the midpoint of KL. So what do you know about a midpoint? A midpoint's in the middle, and it splits that segment in half, and therefore you know that the two segments formed are congruent. So therefore I would know that KM is congruent to ML, and I would go ahead and mark that. Now, I wasn't given that KM was congruent to ML, but because I know M is the midpoint of KL, I now know that KM is congruent to ML, and that's what you mark. And so in this case, I would know that KM segment is congruent to segment ML, okay? So knowing that that was a midpoint implied that those two segments are congruent. Next is if you see a bisector. So a bisector, remember, is something that cuts something in half, whether it be, in this case, a segment bisector, or whether it be a angle bisector, which we'll get to. So we know BD, so BD, I'm going to highlight it, bisects AC. So that BD is cutting AC in half, okay? So I'm kind of extend it just so you can kind of get a visual. So that means this yellow BD is cutting AC in half. So what does that mean? Well, now that's telling you that you should know that AB is now congruent to BC because that cuts it in half. So then we can write that AB, segment AB, is congruent to segment BC. Okay, so now we weren't told that those segments were congruent, but it's implied because we know there was a bisector. Okay, so the reflexive property, you might have learned this back in algebra, but if not, let's kind of talk about it. So what I want you to do is first, we're going to look at the two different triangles. So I'm going to highlight here triangle JKL, and then I'm going to use a different color and I'm going to highlight triangle JML. Okay, so now we see that these two triangles actually share a side. They share side JL. They both overlap. Well, that JL is going to be the same in each triangle. It's the same length. So we can mark there, and that's what we call the reflexive side, when they share a side. So because of that, and I know it looks kind of silly sometimes, but that just means JL is congruent to JL. Okay, so then we know that if I had to separate those two triangles, that distance on each triangle would be the same thing. And so these are the different ways that it implies that sides are congruent. All right, so this is now how you would mark angles congruent. So like with sides, if it's given to you that the angles are congruent, you just go ahead and mark those. And remember, you do the little arcs inside the angles for the ones that are congruent. But then it's also if you're given information that implies angles are congruent. So first of all, you'll see vertical angles, and no one will explicitly tell you they're vertical angles. At this point, you should be able to recognize them. So anytime you see vertical angles, you go ahead and mark those. Okay, so now that we know those are congruent, now we can name them. And remember, we're going to use the 3-letter naming system. And remember, the vertex needs to be in the middle. So I'm going to call this angle NPL is congruent to angle MPO. And we see that the vertex, which is P for both angles, is in the middle. Okay, so make sure that's how you name the 3-letter angle. So again, remember, vertical angles, they won't explicitly tell you, but it's implied in the picture and you have to be able to recognize it. Okay, so now if you have an angle bisector, remember an angle bisector cuts an angle in half. I'm sorry, there should be an angle symbol right here. So if you have an angle bisector that cuts an angle in half, it makes 2 new angles that are congruent to each other. So we're going to go through and highlight here. We have BD. So it's this segment. Oops. Should try to get this a little straighter. BD is going to bisect angle ADC. So remember, start at A, trace down to D, then trace to C. And because it's an angle, we're not going to complete it going up from C to A. Okay, so we know that this yellow line is cutting this angle in half, and if it bisects and cuts it in half, that means the 2 new angles formed are congruent. So that means here is congruent to here. And I'm gonna just mark these like that, just so you can see that there's a different way to mark them. All right, so then we're going to name them. So because this was an angle bisector, it didn't tell you that these 2 angles are congruent, but now we can imply, because we know what an angle bisector does. So now we know that angle ADB, angle AD, oops, sorry. Angle ADB is congruent to angle BDC. And again, the vertex of that angle is in the middle, which is D. Okay. And then what we need to know is the right angle congruency theorem, that if you have right angles, they are congruent to each other because each right angle is 90 degrees. So if you see 2 right angles here, I can say that angle G is congruent to angle K. I can also name it with 3 letters. I can say angle FGH is congruent to angle JKL. Okay, so those are ways to be able to mark your angles congruent. And then we have some more. Another way to mark angles congruent is you have reflexive angles. So the reflexive property with angles works here. And so when we look at these, I'm going to highlight. We have this triangle. Okay. And then we have this triangle. And so they overlap right here at this angle here. And because both of those triangles will share angle B, then we know we can say that angle B is congruent to angle B, or we can actually name the angle. So we can do angle EBA is congruent to angle, and we're going to name it with the other triangle, DBC. So again, that vertex is still in the middle of B. If you have parallel lines, and only if you have some information telling you that there are parallel lines, we can have alternate interior angles, or we can have corresponding angles, which will help you identify what's congruent. So here, you can have Here's a set of alternate interior angles. So we can name that with 3 letters. Angle TQU is congruent to, I'm going to name this angle SRU. Again, the vertex are in the middle. But in this figure, there's also another set of alternate interior angles here. And so then now we can name angle QTU. So again, remember we changed the order because the vertex needs to be in the middle. Is congruent to angle, and let's call that RSU. Okay, so in that figure, you'll see those alternate interior angles. If you look at this other picture, here we know that these lines are parallel, again, because they gave us the arrows on the line indicating that they're parallel. So meaning in this figure, we can look for our alternate interior angles. So we have this one and that one. And so then if we name them, so that's angle ABD is congruent to angle, CDB. And then you can also have corresponding angles. So again, we have parallel lines. They either have to be told to you or shown to you in the picture. And then so we're going to look for corresponding angles. Be here. Remember, corresponding angles are on the same side of the transversal. And they're the same relative position regarding their parallel line. So if I kind of extended this line out, the parallel line out, hopefully you can see that those are the corresponding angles. So now we know that angle VSU is congruent to angle WUT. Okay, and so that's what you get when you're having to either be implied what's being marked or they're going to give you what's marked. And so you want this is going to be very important that you actually mark your pictures for what we're going to do later on. Okay, and that's it.